Good morning and welcome back. I hope you had a restful 2 weeks and I hope that you did take advantage of the sunshine. I know it's limited advantage we can take of it, but I hope you did take advantage of the good weather that we did have, and that you get out and fill your lungs with plenty of fresh air, and that you're ready to embrace this new challenge that'll take us into the end of May and beyond. Look, again, as I said in the email I sent you this morning, if there's anything you do need me to do for you, or any clarification that you need on anything whatsoever, just send me an email. Okay, I'm always at the end of the phone, or I'm always at the end of a computer, so I will respond back to you as quickly as I possibly can. And particularly now that we're back at school, that response will be pretty almost instantaneous. I ain't going anywhere. None of us are going anywhere. So we've got plenty of maths to do and plenty of time to do some revision. Okay, I'm going to go straight into statistics. Now, statistics is quite a large chunk. Again, in your book, you'll notice it's broken up over a number of chapters. I'm taking the whole thing together as one section. Okay, and the overlap of probability is that, again, we're going to be using the normal curve, and we're going to be using the probability distribution in order to help us with statistics. That's where it's more, I suppose, it's where it's better placed in order to help us to deal with things that are normally distributed, as we spoke about before the Easter holidays. But anyway, before we do that, there's an awful lot of theory we've got to go through. There's a language behind statistics that we have to be familiar with before we can get into the actual mathematics of it. So bear with me, because I'm going to hit this thing in one go, and I'm going to go through this and make sure that you understand the terminology and all the various different vocabulary that goes with it. And you'll just have to take time to sit down and learn this, okay? You just stick some earphones into your head, put on your iPad or your phone, whatever it is, and just listen to the terminology that's involved and follow the slides that I'll also put up in Google Classroom today. And I'm going to put the whole batch of slides up today so that you can actually follow it in your own time on the slides, and then with the narration and the videos that I'm going to send you. So without further ado, let's begin. First of all, lovely quote. Yeah, what are statistics? Well, in the world there are three types of statistics, yeah, or three types of lies. There's lies, there's damned lies, and there's statistics. People can manipulate statistics. Okay, just keep that in mind. They can manipulate them verbally, they can manipulate them visibly, they can manipulate them audibly. And hopefully we'll give you a few examples of that as to when we go on. If statistics are properly used, they are beautiful maths. But statistics usually are slightly skewed or maybe turned a little bit in order to reflect favourably on something that somebody wants to highlight as being good. Okay, so watch out for all that as you go along. There's plenty of examples on television with the ads where they've got the tiny print at the bottom telling you that their APR is 2,648%, whereas in big letters at the top, it's a payday loan. Okay, you can get €1,000 now if you pick up your phone. Just watch the small print. That's the golden rule down through life. Watch the small print. So let's begin. Statistics is concerned with the proper scientific method for collecting, analysing, presenting and interpreting data. Now, what are the two most important words there? Concerned with proper scientific methods. Okay, that's the key thing. Proper scientific methods for collecting, analysing, presenting and interpreting data. An unorganised list is called data. So in other words, when you stand outside your house and you count the number of cars that go by and you take down the colour of each car, you're going to end up with an unordered list. And that unordered list is what we call raw data. When you put manners on data, then we enter into the whole world of statistics. Okay, so as I said here in red, when the list is ordered in some way, so maybe you want to highlight your favorite color car, or maybe you want to highlight a favorite car, well then that's information, because when you order raw data, it begins to tell a story. Okay, and that's what statistics is. It's taking in raw data and manipulating it to tell a story. Now, if it's done under proper scientific methods, then that information is good. If it's skewed or if it's biased or if it's manipulated in any way, then that's not good. Okay, and statistics is very, very easy to manipulate. Think of China, think of the coronavirus, think of manipulation of statistics, and you've hit the nail on the head big time. Okay, it's one of the key ploys of a communist country, that they will manipulate statistics in order to make the mother country look really good in the eyes of the rest of the world. Okay, statistics can be descriptive or they can be inferential. Now, the two words there mean, descriptive means tell a story. Inferential means that they lead to new information, that they reveal something. Okay, so just again, the two words are extremely important. If you're descriptive, well then you're talking about the car is red, the car is black, the car is yellow. All right. If it's a case that you count all the colours of the cars and you write them all down and you realise that yellow has appeared 49 times out of 60, then what can we infer? We can infer that yellow seems to be the favourite colour. Get the idea? So there's a difference between the two. Descriptive is cold, inferential is drawing new information out from a set of data that we have just collected. Okay, descriptive statistics, as we said already, involve graphs, charts, tables, and are used to represent and summarize data. It focuses and reduces data to a manageable size. Now again, you remember this from your junior cert. You've got these big tables and they're filled with numbers, and the first thing you're told to do is place the following data into a bar chart or into a histogram or into a pie chart. When you get the picture can tell you more than raw data can, even though they represent the same thing. The picture is what we call descriptive. It's describing some set of data that you've just collected. Okay, and then obviously, as we said already, the inferential statistics, the findings from the sample, are used to draw conclusions. Very simple example: 49 yellow cars out of 60. That's your data. Okay, what's your inferential data? Yellow seems to be the favorite color around this estate. Okay, that's a very simple way to just get you between the two. So a large part of any statistical investigation is the production of data. So how do we get our data? So say, for example, if I want to do a survey around here in the neighbours to say how many people have alarms on their houses, how many people have alarms on their cars, how many people have immobilizers, how many people have whatever they have in their cars, yeah, alarms, etc. I would have to first of all sit down and think, how am I going to collect this data? What am I going to do? Am I going to ring them? Am I going to send something in a letterbox? Am I going to make up an online form that they can fill in? So how do we actually get this data? And that's one of the biggest parts of any, what they call statistical investigation. Okay, and there are 4 parts to this. There is posing the question. So what type of security do you have in your car? You collect the data. Now, how you collect the data, that's a huge question. There are many varied ways. You then take the data back and you analyze the data, turning it into information, and you interpret that information, both what we said descriptively and inferentially. Okay, so these are the 4 areas that we have to look at in terms of undergoing a statistical investigation. Any characteristic that's recorded about an individual or an object is called a variable. Now, where did we hear that word before? We heard the word variable before when we were dealing with algebra. X, Y, Z, A, B, C, all these letters that stand for an unknown number, okay? They're called variables. And a variable is something, obviously, that changes. So as you go from house to house, what's your favourite colour? Red. Next house, what's your favourite colour? Blue. The data you're collecting is changing. So therefore, the data, the colour you're collecting, is what we would call a variable. Okay, that's where it gets its name from. So variables, when you put them into a list, become data. When you put manners on the list, or when you put some type of structure on that particular list, it becomes information. And it's from the information that we get what we need to get. We get the information and we get the story that we want to take from the data we collect. So what types of data are there? So what type of questions can you ask? Well, really there's only 2. Yeah. First of all, there is what's called categorical data. And categorical data is when you would ask somebody, for example, what's your favourite colour? The first thing they're going to say to you is red, black, blue, pink, green, yellow, orange, whatever it's going to be, okay? But they're giving you back a word. So when somebody answers you with a word, like red or black or yellow, or simple thing, how do you think we did today? You know, when you go to the supermarket at the end, how do you think we did today? Good, bad, not happy, very bad, yeah? That is categorical data, because what you're collecting back is a set of words, okay? Now, when you take that categorical data, let's take the first one. Let's say you go around to the neighbours, you knock on the door and you say, what's your favourite colour? Not only will they think you're mad, but then they'll say afterwards, well, blue. Yeah, and they close the door and go, your man's after asking me what's my favourite colour. Anyway, they'll say blue. When you take all that data back and you look at all the colours that people have given you, can you seriously say that there is any colour more important than another? Is black more important than red? Is red more important than blue? Is there any hierarchy within the colour structure? The answer is no, there's none. So in that case, your categorical data is called nominal. In other words, nominal, it comes from the Latin word nomen, which is name. It just means you've got a list of names. There is no order of importance in there, so therefore it's nominal data. If you go to the second one and you ask people, say for example you knocked on the door and you said, what are your exam grades? Okay, and they say, well, I got 3 A's, 4 B's and 4 C's. Do you notice the way they call out exam grades? And when you get yours, please God, next whenever, before Christmas hopefully, when you get your exam grades, the first thing you're going to do is you're going to ring Granny and you're going to say to Granny, Granny, I got 4 A's. Yeah, I got an A1 in maths. You're not going to say, Granny, I got 5 E's, because E is kind of the end. Yeah, they don't talk about them. So is there an order of importance in terms of your grades? Yes. So what does that mean? That means we're talking about ordinal data. There is an order to the data that you're collecting. There is a hierarchy present. There is an order of importance. Okay, so think about it again. If you collect data that is given back in the terms of words or descriptions, you're talking about categorical data. If those words that you collect have an order of importance, they are called ordinal data or ordinal variables. Okay, if it's a case that they don't have any particular order or hierarchy of importance, then they're simply nominal data, which means you collect them and you present them in no particular order. You know, when they do that, they often say that, and here are the winners in no particular order, or here are the finalists in no particular order. So they're all finalists. It doesn't mean that one is better than the other. There's no particular order. That would be nominal data. On the other hand, if you were to say to somebody, how many people in the house? 5. How many people in the house? 7. How many people in the house? 2. Okay, if you were to go around and ask somebody a question that gives back numerical data, where they answer you with a number, well then, as you can see from this box here, that's what we call numerical data. When somebody answers you with a number, how old are you? Yeah, 21. Yeah, how many children in the house? 4. How many cats do you have? 0. Once they answer you with a number, you're down in the second category. You're down into what we call numerical data. Now again, numerical data can be of 2 types. If you ask somebody, how many children do you have? They're going to answer you with an integer. They are even a natural number. They're not going to say -7. They're not going to say 2 3/4. You can't have 3/4 of a person. You have a person, end of story. No matter what way the person is, you have a person. Done. Okay. So if you ask somebody, how many children do you have? What you're guaranteed to get back is a natural number, including 0. All right. So therefore, there are only certain values that they can answer you with. There are certain values that they can never answer you with in terms of how many children do you have or how many people are in the house. All right, so think about that. If that's the case, if there are only certain values that are available for their answer, that is what we call discrete. And the word discrete in mathematics means an actual value, a certain value. Okay. In chemistry, those of you studying chemistry will know that when we talk about the electron has discrete energies. In other words, there are certain energies that the electron can have, and there are other energies that it simply can never have. So when we talk about discrete, we talk about definite, okay, definite values, leaving out some values that it'll never actually have. Now, take for example then, you knock on the door and you ask somebody for the heights of everybody in the house, okay? They will give you back a range of values. Now, I want you to think about something, and I want you to think about this carefully. From the time that you were able to stand up and walk to now, all right? Say when you started walking, let's just say you were 2 foot high, okay? Today, taking some of you at 7'3" or something, in this generation seems to be all huge. So, is there any height in between those two that you skipped? So you started walking, you were 2 foot high. Now, you're 6'2". Is there any value between those 2 bookends that you skipped, or that you were, way to put this, are there any of those heights that you never were? No, you went through every single one of them from 2 foot to 6'1", okay? Every single one of those were covered. So therefore, between those 2 bookends, every value is available and every value has been used. That's what we call continuous data. So if your data that you're collecting is in number form, then it's numerical data. If the numbers are only of certain value, they are discrete variables. If your data can be a range of values between any 2 given points of reference, then that's called continuous data. And you can read that slide for yourself because there's a number of examples that are present in there. Okay, primary data. So when you go around the houses and you knock on the doors and you ask people, how many people do you have in the house? Many grandparents living with you, many kids, etc., etc. That's getting data firsthand. That's you collecting your own data. And when you collect your own data, that's called primary data. Okay? If, for example, you were to go to the register down the road in the local library or down at the local registry office and look up to see how many people are eligible to vote in each house, what you're doing is you're collecting data from data that somebody else collected. Now, that's not primary data. Unless you go and collect the data yourself, then we can't call it primary data. All right? That's called secondary data. So, for example, going to the Guinness Book of Records. If you go to the Guinness Book of Records and you want to look up who's the tallest person, it's all there in that book for you, because somebody else has gathered all that information, has put it into a book, has allowed that data then to be available to everybody else. So the Guinness Book of Records would probably be secondary or tertiary data, depending on where they got their sources from. So unless you gather the data yourself, you cannot call your data primary. If you stand out at the bottom of the road and you stand there for 4 hours and you count the number of cars and the colours that they have, then the data that you collect can be considered primary data. Okay, so just get used to that word. In an observational study, the researcher collects the information of interest but does not influence the events. So you're standing there with a clipboard and a pen and of course a big smile, and you're ticking away blue, blue, yellow, red. Okay, that's collecting primary data. Observational studies also include case controls. Now, nowhere better than in the study of trying to get a vaccine for this damn virus. Okay, there are going to be a number of case control studies. So for example, if you've got 20 people who've all volunteered to test a vaccine, some of them will be given placebos, some of them will be given blanks, in order to make sure that if there is any reaction to this particular vaccine, that it comes from the people who got the vaccine itself and not from the people who got nothing. All right, so this kind of case control, it just allows me to have results that I know I can, what word would I use? I can compare. That's the best word to use. So if I have a case control, I have one set of data that I already know the outcome of, and I can compare the rest of the data then that I get through those who get the vaccine to the ones who don't have it. Okay, that's what we talk about case control studies. Designed experiments are just that. I mean, a lot of this vocabulary is actually kind of quite self-explanatory. Designed experiments involves applying some treatment to a group of students and then observing the effects of the treatment. So, for example, getting the news that you don't have any school for the rest of the year. How have people reacted to that? Some have reacted, oh, brilliant, yeah? Some have kind of gone, oh, my structure is gone. Some people really panic because they need the, I suppose, one-to-one tuition or the face-to-face contact or whatever it's going to be. So a designed experiment would be where all students get the same treatment and then their reactions to that treatment are actually recorded. The item applied is the explanatory variable and the effect, say for this case here, of a drug is called the response variable. So I'm thinking in terms of the virus at the moment. So if you apply a drug, if you administer a vaccine, what we're doing, we're exploring what the vaccine is going to do. So by applying the vaccine, we've got what we call an explanatory variable. And then you wait and you see, you watch. Is there any reaction? If there is any reactions or any effects, that's called the response variable. So the explanatory variable is the injection itself of the vaccine, and then the response variable is how people respond to the treatment that they have received. Obviously, some people, as I said already, will be given controlled blanks where there will be no vaccine. That's called a placebo, because some people, when they're given placebos, they start to, funny enough, develop reactions to nothing, because the mental state, the mind, is a very, very powerful thing, and they can actually show developments towards something that they think they have received. Okay, so a placebo is a substance that has no therapeutic effect. So you're injecting saline solution, which is nothing more than adding to the plasma of the body, or just giving them water with a certain amount of salt. That's exactly the same content as the human body. Secondary data then, as I told you already, is not collected by the person who's going to use it. It has already been collected by somebody else. Okay, so if you go to look for the results of the census, all the results of the census that you take, that would be secondary data, because people out there have collected the data by means of a form. Okay, so the government, when they get their information, the census would be primary data to the government, but secondary data to us. Okay, sample surveys. A census. We all know a census is carried out in this country every 4 years. Okay, it's a survey of the whole population. Now, every 4 years, it's not feasible to do a census every 6 months. The amount of work that's involved in getting, whatever it is, nearly 5 million questionnaires out, okay, taking them back in, correlating the data, it's massive. So therefore a census is only done on a very, very sparing time frame. Here in this country, it's once every 4 years, all right, because of the amount of work involved. So therefore, we can't ever survey the whole population. So instead, what do we do? So if Lidl, for example, wants to find out, what do people think of our cheese line? All right. What are they going to do? Send out an envelope to every household in the country? No. By the time they did that, they'd be bankrupt. So what do they do instead? They take a sample. They get a sample. Now, we've got to be very, very careful with the samples we gather, because if we want to get our data to be a true reflection of the population, well, then the sample will have to mirror the structure of the population. Okay? So men and women in equal amounts, young and old in equal amounts. So you're going to have to make sure that the sample you gather to test reflects in some way the population as a whole. And your hope is that the results from the sample will mirror the results from the overall population. So it's a nice way for those involved in statistics to get results that might reflect what the feeling of the country is at any particular time. Those of you interested in politics will know that way before the election, they start this thing of the Red Sea poll, the exit poll then on the day itself, etc., etc., trying to get a flavour of what's going to happen in the general election by grabbing a sample of people to see how did you vote. And based on the sample that they have, if it's a good sample, they can kind of predict what may happen on a national level. A sample, as we said already, is a smart or a micro part of the whole population. Okay, now the major population itself, that's macro. Macro means big, macro means whole. Okay, micro then means a small part. So a sample is a small part of the whole population being studied, and a sample has to be random. Now there's a bit of a difficulty there, because if we're going to randomly select a sample and we want the sample to reflect the population, sometimes if you're doing it randomly, you might end up with a sample that doesn't reflect the population at all. But if it's random, it has to stand. Okay, if you try to model your sample, then you're introducing bias, because you're creating a sample that you think fits the population. So you can't do that. Randomness has to be a huge thing in terms of selecting a sample. So, for example, taking a number of a hat. So if we have 30 students in the class and I want 5, what do? Instead of saying, oh, I'll take him and him and him and him and no hers, no, put all the names into a hat, pull them out randomly. I may still get 3 boys and 2 girls, but as long as it's done randomly, I can rest back and say there's no bias involved. And having no bias is a huge thing in statistics. Sample surveys involve working with statistics and parameters. Now, again, 2 words, and you'll see them in red in the second paragraph. A numerical measurement is a statistic. What's your height? 5'2". That is a statistic, okay? Because it's an individual numerical measurement. So if you take your sample of people and you start asking them about their heights, hoping that first of all they're randomly selected and they kind of reflect in some way the major population, then the data that you're taking from the sample is a statistic. Okay, if you were to take it from the entire population, as we do in the census once every 4 years, that would be a parameter. So micro is a small sample, data from a sample is a statistic. Macro is the entire population in which we carry out a census, and the data collected from a census would be a parameter. Last line, when a sample is biased, then a rule is distorted. Simple as that. You bring in something that might favour a given variable. All right. So a sample is biased when a rule or a distortion is engaged to select elements. So for example, say you line up all your students, but you line them up boy, girl, boy, girl, boy, girl, and you say, right, I'm going to take every second student. Then you're going to end up with all girls. Okay. So you've already put a rule in by lining them up boy, girl, boy, girl, boy, girl, and selecting every second one. And that distorts what you actually get as your sample. So a sample can't be biased. If it is biased, then the statistics are absolutely worthless. In fact, as we said at the beginning of this thing, there are 3 types of lies. There's damned lies, and there's biased statistics. Okay. So what is a sample? Well, a sample is a small part of the population that is selected for surveying. So I don't know whether you've ever got a phone call, or your parents have ever got a phone call at home, always at tea time or dinner time. Can't understand why. Maybe because they know people are having their dinner at that time. Hello, this is such and such MCN, or this is a Red Sea poll. We'd like to know if you do. I put the phone down before you finish the sentence. But would you do a survey or something? No. But they're just randomly going through the phone book. La-di-da-di-da, flick up the page. Let's go into the O's. Yeah, we'll have him. He should be home for dinner. Yeah, they ring you. Will you take part in the survey? No. Now that's randomly selecting. Okay, so a sample is a small part of the population that is selected for survey. A random sample is one in which every member of the population has an equal chance of being selected. Now, even making random telephone calls is not a random sample, because not everybody has a phone. Okay, or not everybody has a phone number that is in the phone book. Some people keep their phone numbers private. So straight away, by you saying, I know what I'm going to do, I'm going to go to the phone book and I'm going to ring people randomly, then you're only selecting your sample out of people who have said, yes, you may publish my phone number. Of those people who want their numbers to remain private, they're excluded. So straight away, there's a distortion. And if there's a distortion, there's a bias involved. Okay, the selections have to be made independently. Did you ever watch the lotto draw? The lotto draw, yeah? And first thing you'll notice is that they say, hi, welcome to the midweek lotto draw, blah, 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 blah. And our independent assessor is, and the camera pans over and this guy nods his head. See, they have to be made independently. So there's an independent there to make sure everything is above board, that the lotto draw is purely random, that the numbers that are selected randomly with no bias. Okay, so it's an important part of that particular draw. So selections have to be made independently. That you're not going to pick up the phone book and say, I know what I'll do. I'll ring me Uncle Fred, I'll ring me Auntie Jane, I'll ring me Cousin Joe, and I'll ring me Dad. There's me sample. No, because they're people you know, all right? That's huge bias. So therefore, independently and randomly, that's the key thing. Sampling can be made with replacement or without replacement. Go back to probability. Do you remember that when we selected a card from a pack and we didn't replace it? Do you remember the effect that had on the probability of the next card? It affected it. It dropped the denominator from 52 to 51. And if we took another card and didn't replace it, it affected the future probability of the third card. All right. So replacing or non-replacing is a very important aspect of the sample I'm going to create. Because if you create a sample, sample, and then you use that sample, and then you throw the people back in again, they're available for a second selection. And the chances are they could be selected again. It might be very, very slim, but they could be selected again. Otherwise, what people might say is like jury service, for example. If you're selected for jury service, it is on a purely random basis. All right. However, once you've done your jury service, you're then exempt from jury service for the next, I don't know what it is it 5 or 10 years or something like that? So therefore, you are selected as a sample who sit in the dock representing the Irish people, making up their mind on a given case. But then you're told after your selection, we don't want you for any future jury for the next 10 years. So therefore, the sample, or the population out of which we then select the next sample, is smaller. Okay, so everybody else's probability of being selected goes up slightly. So that's what we talk about, replacement or non-replacement. And again, you'll notice all these things are there in everyday life. In cases of large populations versus sample size, there's practically no difference in sampling with or without replacement. Think about this. You have what? In the island of Ireland, you have maybe 5.5 million, 6 million people. You take 9, or is it, I'm not too sure, is it 9 or 11 for jury service? It could be 11. 11 for jury service, okay? Now, those 11 don't have to do jury service for the next 10 years. Are the other 5,989, whatever it is, I can't remember, I probably said 11. Are the rest of the population quaking in their boots that they're going to be called next? No. Does their probability go up by a huge amount? No. It goes up by a number that is so small that basically it keeps the probability the same. So when you're dealing with millions of people and you're selecting a very small sample and you don't replace those people back into the population, the probability being selected for your second sample of the people remaining remains exactly the same as it was beforehand. Okay, so if it was a case that you had 5 million people and in your first sample you wanted to take 2.5 million, well then the other 2.5 million better watch out, because their probability being selected now has gone way up. All right, but if you're only selecting 10 out of 5.5 million, it ain't going to affect the probability of selection for the next selection or the one after that. So that's the reason why jury service, as they say already, everybody has the same probability of being called, even though those who have done jury service will not be replaced for jury service for the next 10 years. Okay, just to give you an idea. So there's your population of the island of Ireland, and there's your sample. Call it a jury service, or call it doing jury service, as they say. If the sample is tiny compared to the population, then the overall, I suppose there's no difference, the overall probability being selected in a second sample remains exactly the same, and for a third sample remains the same, etc., etc. So how do we sample? How do we select our samples? Well, simple random selection. So for example, I could walk into the class and I could simply say something like just 1, 2, 3, 4, done. Okay? Or I could say, anybody who's not wearing a tie, out. Yeah, done. Anybody who has forgotten their uniform, out. Anybody who has 2 red pens in a pencil case, out. All right, just some random variable that I can use to throw at you to try and pick people. Lottery method. Put them all into a hat, take out their names. Okay, that thing of spinning the wheel, some of you might have used it in primary school. All your names are on a wheel and you spin the wheel and it lands on somebody and that person gets asked a question. That's a lottery method. Extremely tedious. All right, if you're going to use a lottery method, the first thing you've got to do is get all the names into a hat, cut them all up, and then draw them. Okay, but it's free from personal bias. You can't see into the hat or into the bag, wherever you're picking it. Like, take for example, you go to the Christmas pantomime and there's a raffle and you're asked to pick out a ticket. What do? You turn your head away and you put your hand into a bag to pick a ticket. All right, because you don't want any bias involved. So there will be absolutely no bias because you don't know. You're picking out one ticket. All tickets have the same probability of being selected, and you're going to choose one without looking at it. So it's free from personal bias. The sample may not be unbiased. Now, what do I mean by that? Well, if you're selecting randomly, and I told you this already, if you're selecting randomly, say for example, anybody not wearing a tie, out you come. That's all the girls straight away. So therefore, even though I've selected randomly, the sample is biased. All right. So randomness does not exclude bias. Just keep that in mind. Just because something is randomly selected does not mean that there is not going to be any bias present. There's no personal bias, but there could be a bias in the sample itself when you look and see what you've selected. All right. Sometimes a computer simulation may be used instead. So at the moment, in terms of the spreading of a virus, this is what we would be using, computer simulations, to see how could this happen, how far could this spread, what are the numbers we're expecting. And I think they got it very wrong in the beginning, because they were saying that we were going to be dealing with over 1,000 deaths a day if we were dealing with this thing spreading very, very widely. We're nowhere close to that. Thank God we're nowhere close to that. But it just goes to show you that with computer simulations, again, you're asking the computer to develop a model on probably pre-existing data, and it has to go forward in randomness, into the unknown, and try and predict what's going to happen. A lot of these computer simulations can be right, but a lot of them also can be very, very wrong. Weather would be one example, where the computer simulation is, sun for the next 3 weeks, and you get sun for 3 days, then it lashes for the next 2.5. Okay, that can happen. That's computer simulations for you. So, as we said already, you might, for example, say, okay, you might hand out tickets, and you might say, right, can I have person number, or take it out of a hat or something? I don't know what way you do it, but that's what we would say a simple random sample. It's a lottery method. Okay, and there's a picture showing number 2, number 4, and number 5 have been selected. Now, they're randomly selected, but there's bias. Why? Because there's 2 women and 1 man. So therefore, it's free from personal bias, but there's a bias present in the sample towards women over men. So be careful with that. Second one, stratified sampling. Those of you doing geography will understand stratification very, very well. It's layering, okay? It's layers. And basically with stratified sampling, you're using natural divisions. It ensures that all sections of the population are adequately represented in the sample. So if you wanted to choose a sample that represents the entire population, you would have to take males. There's 1 strata. You would have to take females, 2nd strata. You would have to take boys, girls, 2 more strata. You would have to take young and old, 2 more strata. Okay, you would have to take teens, etc., etc. So you can see straight away that within a given population, there are a number of strands that need to be represented in my sample. And if I start to do that and start to stratify, then I can guarantee that the sample I'm choosing will be very, very similar to the overall population. Okay, so by stratifying your sampling, you're ensuring that all sections of the population are adequately represented in the sample. We must know the proportion of the population in each natural stratum. So that goes without saying. If you want to create a sample that's going to hopefully represent the population, then not only do you have to represent all strata, you've got to know the proportion of the population in each natural stratum so that that can be reflected in your sample. Strata must be exhaustible and mutually exclusive. Now, men and women, see? Mutually exclusive. You can't be in both selections. You're one or the other. Simple as that. You have under 4 years of age, over 4 years of age. And again, what have you got? You've got strata that are mutually exclusive. So that eliminates the chance of being chosen twice. So there's an example. There's your total population. You've got white circles. You've got orange squares. you've got white squares, you've got green circles, you've got red triangles. There's the natural population with their strata. So what do? They order them into the strata. Now this could be men, women, it could be male, female, etc. Men, women, it could be over 60, under 60, it could be teenagers, it could be children, whatever it's going to be. But when you bring them into their strata, you then select the first of each of those strata, which means, look at your sample. Your sample has exactly the same constitution as your population. And what you're hoping then is that your sample, when you do experiments on them, will be, not Frankenstein experiments, I'm talking about numerical astronomical questions and so on. When you do experiments on the sample, you're hoping to get data that will reflect the population. So it will, when you stratify your sampling, you can be guaranteed that your sample will match the configuration of your population. Okay, and that sometimes is the way that they favor getting samples, particularly when they're doing a research poll over the phone, or if they're doing a thing in relation to voting, which would be everybody over 18, but it has to be male and female, etc. Okay, systematic sampling. Now again, it's a type of sampling, the name gives it away, it's systematic. So in other words, there's a method behind the whole thing. Okay, so you have a method. How are we going to do this? So people sit down and say, I know, here's what we will do. And they come up with a method and they employ that method for their selection. They choose perhaps the first member randomly and then choose every sixth person until the sample is filled. This is just an example. So they might have 50 people over here. All right. Okay, let's say we'll choose you, random. Don't know who they are. I'm going to choose you. And then each person is given a number and you say, okay, can people who are holding multiples of 6 please step forward? You've got your sample. All right. So there's a method behind it. Regular intervals cause problems, especially if they are intervals of time. So if you're using, say, every 3 weeks or every 2 years or every, for example, a census, every 4 years, all right, there is problems involved in time because things change over time. Time is an independent variable and everything else based on time is a dependent variable. So therefore it responds to time, and that response to time causes slight problems in terms, not for a census because the population is huge, but in smaller samples there can be, say, shifts in population in and out of a town. So you do a sample to see who likes my butter every 4 years. You've got a different population perhaps every 4 years. So you've got to be careful that if you're doing them regularly over time, that the problems that you're going to encounter, like a different population, you never asked me before. Oh, you get a completely different cohort of people living in the town, or maybe due to natural death and so on, and then new additions, it changes. Okay, so there's an example. Every third person. All right, so therefore you select one at random, let's say number 2, and then you take the 5th one, the 8th one, and the 11th one, and you end up again with your sample. But look at this sample here. Again, this sample is biased, right? No personal bias, but it's biased because it has 3 red individuals and 1 green. Blue didn't even get a look in. So therefore we cannot say that this sample represents fairly the population which it came. Okay? It doesn't do what stratified sampling did in the previous one. Okay, cluster sampling. A list of groups and individuals rather than the individuals themselves. So in other words, you're going to cluster, all right? A cluster, you know what a cluster is. A cluster of nuts is where you get a group of nuts all growing in the same place, okay? So a list of groups or individual rather than the individuals themselves. Random samples of groups are taken and every individual is observed. So perhaps you might just say to yourself, okay, do you know what I'm going to do? I'm going to sample the 9 o'clock mass goers. Now that's a group that kind of stays the same from week to week to week. All right, people who get 9 o'clock mass on a Sunday are the people who get 9 o'clock mass nearly every Sunday, unless they're heading off to Crow Park and they want to get the early mass to get in there to get their seat. Okay, but usually the people at 9 o'clock mass are fairly solid. All right, so you could say, right, we're going to we hit the 9 o'clock mass goers. So people might say, for example, going up to a general election, what mass has the biggest number of people? Oh, the 11 o'clock mass, right? We go down there and we stand outside the church gates. So what they're doing is they're taking a random sample, they might choose a random church, but they might try and find out which one has the biggest population. Okay. Popular in the sciences, for example, like a quadrat. Now, those of you studying biology will understand this. A quadrat is a square 1 meter by 1 meter. You take a pen, you throw the pen over your shoulder, it lands somewhere, and you put your quadrat over it. So what you have then is a cluster of plants. And that cluster of plants in the 1 meter squared is analysed to give you statistics on how many are present at meter squared, what type of plant is present at meter squared, and you can get some lovely bar charts. Okay, you can get a bar chart of distribution of a plant, and you can take it that you do a number of these quadrats over a given field, and then when you bring all the results back together again and look at all the bar charts, you've got a fairly good idea then of the distribution of plants over a given area. Right? Beautiful example of what we would say cluster sampling. Large number of small clusters is referable. So you don't just throw the quadrat once. You do a quadrat a number of times to get a picture in your head of what the distribution of plants over a given area is. Now you don't quadrat the whole damn place. You'll be there all day, okay? You take maybe 10 quadrats over a huge big field, and then you bring that data back, and that hopefully then will reflect how plants are distributed over that particular given area. Okay, multi-stage sampling. If we wanted 1,000 people in a sample, we could choose, and this is kind of, again, it's kind of like layering, all right? It's a little bit like stratified. You could take 5 counties, randomly select 5 counties, okay? All counties beginning with K, so you could do it that way. 4 towns in each county, again, randomly selected, and then 50 people in each town. So it's a little bit like stratification, except you're actually dealing with 5 random towns, then in there, 5 random counties, then in there 4 random towns, then in there 50 people. So it's like a cone, okay? You're homing down into one group of people, but you're picking their area, hopefully randomly. Random counties, random towns, random 50. So very similar to stratification, but we call it multi-stage. So it has layers rather than strata, it has layers. 5 by 4 by 50 is 1,000 people in your sample, which is quite a decent sample if you're going to do any type of marketing. Okay, so there's just an example. Shanghai, China, seen as in the news. Shanghai, we go to 3 districts. From those 3 districts, then we go to blocks or towns, which are randomly selected. And then from those blocks or towns, we get into residential areas, and then we select 50 people from each residential area. You can get quite a number of people quite quickly if you're dealing with this kind of thing. Quota sampling. Now, you've all heard this. Those of you who love politics, I hope there's none, but those of you who love politics will understand the quota very, very quickly. A quota is a number. It's a magic number, okay? So when we talk about quota sampling, we're talking about some type of magic number. A quota for different sections of the population are set, all right? So therefore, there is a limit. That's what a quota is. There's a limit on the number of people who can actually take part in any one particular sample. So just say, for example, that you want to start up a new council, okay? And the council has to be equally distributed between men and women. Well, then if the council is made up of 10 people, there will be 5 places reserved for men, 5 places reserved for women. How you select them would probably be through election, but it could be randomly if you wanted to start this thing from scratch, okay? But there's a quota on the number of people that can represent any one group. So just a limit. That's basically what a quota is. It's a limit. When you're running for election, there's a quota over which you have to get in terms of number of votes before you can be elected. So if you don't get to the quota, you're not elected. So the person at the bottom is eliminated and their votes are distributed upwards, and that lifts you a little bit more. And when you reach the quota, hooray, you're elected. Not that you want to be, but you're elected. It's used to ensure that the sample contains members of the population in the desired proportions. Now look, gender balance is a huge thing these days, very, very important. So we've got to make sure that when we're creating groups of people, that there must be some type of quota on both genders to make sure that they're equally represented. The interviewer, however, can be a source of bias. Now, you might have your quota set up, you might have the right number of people in each particular category, but the questions that can be asked are coming from a human mind. And human minds are easily biased towards tweaking questions to get what they want to get for their use. So go back to personal bias, okay? If there's an interviewer involved, personal bias will be huge. And this is also an example of non-random sampling. Why is it non-random? Because there's a limit. If it's random, there's no limits. Okay, a council is to be selected. Let's choose 10 people randomly. You could end up with 10 men or 10 women. You could end up with 8 women, 2 men. You could end up with 2 women and 8 men. But because there's a quota set, there's only 5 spaces available. They can be randomly selected. But once you cap randomness, it's no longer random. Think about that, okay? So, panel sampling, the last one. When you want to get a panel together, all right? So if you ever watch the Late Late Show or one of these chat shows, you'll always have a panel. The panel, again, should alternate male, female, but it should also come from different sections of interest. So if you have a huge societal questions you want to debate, you should take people from both genders. You should take people who are for this particular amendment or this particular change, and then you should take people who are not for this particular change to make sure that not only is there balance in the gender, but there's balance in the viewpoint, and that's important about a sample. So collecting data from the same sample on more than one occasion. Used to measure changes in behaviour or opinions. So you'll always notice when a huge thing is coming up for say constitutional change or something like that, they'll always have panels out. And the panels will always be 5 or 6 people. Look at the presidential election, for example, a panel, yeah, men and women, and they all put forward their case as to why they want to be president. But take, for example, then, say, if you wanted some kind of constitutional change on whether the school-going age should be raised to 21, okay? You'll have people who say, yep, definitely 21 years of age. Then you've got people who say, absolutely no way. They should be left at 17 or 18, or they should be left at leaving cert age. So in that panel, again, you've got to have a spread of genders, but you'd also have to have a spread of what we would say would be viewpoints or opinions. Okay, so spread of opinions and also spread of genders. Members are prone to fatigue or learning responses and so on. So if you know you're going to go into a chat show and you know you're going to be asked a question that's difficult in terms of constitutional change, you're going to have your answers already in your head. It's not going to be spontaneous. Okay, so therefore, if you learn your answers, or if this panel discussion is going to take 3.5 hours, people get tired. Go onto YouTube and just look at some of the panel representations for the presidential elections, and look how tired people get so quickly, and how they screw up, and how they answer stupidly, and how they're eliminated. So there's fatigue, but there's also learning responses. You'll often see them when they're asked a question, pick up their pen and they write down an answer. They got the answer there and they want to deliver this answer by hook or by crook. This is what they want to get across. Okay, so they can actually tweak their answers in order to not suit the question, but to suit themselves. Panel sampling is non-random, obviously. There's an example. Okay, if you notice that panel there, 1, 2, 3, 4, 5 men, 1 woman, it doesn't actually reflect the population at all. So therefore, there might be free from personal bias, and it might be free, but in this case here, panel sampling is not random, because you have to select somebody with a given viewpoint. Okay, and once you have to do something, then it's non-random. So, what about ethical issues? We're nearly done. Ethical issues always must be to the fore with a questionnaire. This is what makes statistics so dangerous. If statistics are done unethically, then the information that's gathered, first of all, is dangerous, but it's also absolutely useless, because it does not follow ethical guidelines. Okay, the most complex issues of data ethics arise when we collect data from people. Now, you know, at the moment we've got this GDPR, okay, information, data. How do we deal with this? We've got 2 major rules: the Freedom of Information Act, which means you are free to get any information that's pertaining about yourself from anybody that holds information on you, and the Data Protection Act, which means that if I hold information, I have to make sure that it's protected, that those who are not legally obliged to see it can't see it. Simple as that. Informed consent and confidentiality are the 2 most important issues to be considered. So you'll often hear sometimes when you ring up the insurance agency or something, they'll tell you, the very first thing they'll say is, this call is recorded for training purposes. No, it's not. This call is recorded because if you go back with a complaint, they can say, well, hold on a second, on the 2nd of December here, you rang me giving out yards about something. They have your backlog of data there. So they have to tell you that they're recording you, and they're going to hold your data. They say for training purposes. No, it could be simply in order to make sure that if you come back with a complaint, they've got the data they need to say, well, you were quite happy when you rang us on the 2nd of December, etc. Clinical trials, which are underway at the moment in terms of trying to find a vaccine for this COVID-19. Okay, the clinical trials are experiments that study the effectiveness of medical treatments on actual patients. Now, I was lucky enough at one stage to belong to the ethics committee of Tala Hospital, and if you ever get the chance to be a part of an ethics committee of a hospital, take it. It's a massive eye-opener. It's a huge eye-opener. The way they have to treat their patients, the data they've got to give them, how they protect the data, etc. It's just a huge eye-opener. But it is an ethic. Every hospital has to have an ethics board to make sure that any trials they do are done ethically with the full knowledge and consent of the patients involved. Clinical trials raise a number of ethical issues. First of all, the patients have to be told, well, you know, this is experimental, so this could harm as well as heal. Secondly, the benefits, if there are any, will go to future patients and not the present ones. If a treatment is proving effective, is it ethical to continue knowing that those who are not receiving the treatment are not going to get better? So if you can see that the 5 people over here getting the treatment are improving, and the 5 people over here with the same illness getting the placebo or getting sicker, do you stop and give it to everybody, or do you keep going to the end of the trial? All these things are discussed. They make for absolutely enthralling conversation if you find yourself on one of these ethics boards. Anyway, let's just talk about a little bit about sampling, bias and sampling. We know what it is. Bias is any kind of rule or unfairness or anything that distorts your data. Okay, failing to identify the correct population, sample size being too small. Well, you know what? I'm going to get 2 people to represent the whole entire population of the island of Ireland. Rubbish. Even 100, too small. You need a couple of thousand before you could actually get any decent sample. Careless or dishonest answers to questions. Okay. We've got misleading or ambiguous questions. So questions that are phrased in a certain way to confuse people. We've got no responses. So for example, you might send out 50, 60 questionnaires, you might get 3 back. Is that good enough? Is that a good enough basis to build your data? Well, see what type of data you get back. Errors in recording your data. So people might transcribe wrongs. When you're putting in census data, there's going to be human error in there. That's why we have a plus or minus 2%, what we call margin of error on either side. We talk more about that later on. Or old data. For example, how many car owners in 1972 versus 2012? You can't compare the two. Totally different times, totally different emphasis on a car, and totally different traffic volumes as well. Okay, so how do we choose a random sample? Well, suppose we were asked to generate a random sample of size 20 from a population of 1,000. We can use the calculator. So if you're told in your exam, which it probably won't be in terms of the time allocation given to you, but you can actually use your calculator. You simply press 1000 shift full stop equals to get the first one. Now you can try this in your calculator yourself. So 1000 shift decimal point equals. And what that will do for you is it will tell the calculator that you want a random number between 0 and 1,000. All right, and every time then you press equals, it will generate a new number. So you can randomly get a set of data from your calculator, quite easy. You press equals 19 more times and you'll get your 20 sets of data. Okay, so that's just a quick way for you. If you ever want to just get a random selection of data, get the calculator. It has no intelligence, it's electronic, so therefore it's completely random. Why do we use random samples? Well, fast and cheap. They're essential when sampling units are destroyed, for example, the lifetime of a bulb. So you've got to make sure that you simply continuously select samples to make sure, okay, how long did the units of the bulbs last in that particular sample, etc., etc. And then if they're destroyed, you've got to select some more. Quality of information gained is more manageable and better controlled. So if you're going to use a sample, you can control it better. Imagine trying to collect some data from 5.5 million people. No, take a sample, it's easier to control, it's more manageable, okay? But difficult to gather data on a whole population. That's why it's only done once every 4 years. That's why a census is only carried out once every 4 years. It's a huge operation, all right? Massive undertaking. And even when they're finished, they still don't get back the data. There are still people out there who forget to send it back, or people who die during the process, or whatever it's going to be, but they don't get back a full set of information. So when you're collecting your data, and this is another circular method of looking at how to collect our data, you pose your question, you collect your data, you then present your data, be it as a pie chart or a bar chart, whatever way, you then look and see what the pie chart, the bar chart, the trend graph is trying to tell you, you interpret your data, is it descriptive or inferential, and then when you find it, you present your findings, and then you may pose the question again in 5 years' time, okay, to see how things have changed. Has the population mood shifted? Is the opinion of the population any different now to the way it was 5 years ago? And so on. So, when you're designing a sample survey, you've got to design a form. Now, Google Forms is one of the greatest ways to design a form for electronic use, okay? And electronic use is very, very fast and cheap. You design the form, you email it out. Problem? The response levels are quite low. So every type of survey that you design has pros and cons, and that's what we're going to look at here. So this is a survey that collects data from a sample of a given population. Data is collected by well-designed questionnaires, and methods are employed, like talking to the person face-to-face, by ringing them on the telephone, by sending them out a questionnaire by post, or by designing an online form. Now we're just going to take a quick look at all of these, and then we'll finish at this. There's the method, personal interview, face-to-face. When you're talking to somebody face-to-face, what are the advantages? Well, there's a high response rate, because when they stop to talk to you, they're going to engage with you to the end, okay? You can ask as many questions as you want, because once somebody stops, they're in, all right? And you can ask more personal questions as you go along. Problem is, it takes people to run them, so there's wages to be paid. And the interviewer might manipulate the questions depending on how honest they feel the respondent actually is, or how manipulative the researcher is, and how manipulated the person who's answering the questions can be. Telephone survey, expensive. There's money involved in making telephone calls, okay? And when you're not looking at somebody face to face, when you're answering somebody over the phone, you can lie. They can't tell. So one of the greatest disadvantages to a telephone survey is lying, people telling lies. Postal survey costs money. The return is minuscule. So therefore you'd have to send out a huge number of surveys to guarantee a 3 or 4% return. Online questionnaires, they seem to be the best these days. They're cheap, they're fast, they can collect large amounts of data. The machines themselves can actually manipulate the data into pie charts and bar charts, etc. very, very quickly. But the problem is, as we said already, if you don't have a computer, or if you're, say, in a household that doesn't have technology, you're excluded. So straight away, if you're excluding a body, you're not going to get a sample that represents the population. And lastly then, what about observation? Just standing there, ticking a board, yellow, green, blue, red, big, small, 5, 6, 7, etc., whatever it's going to be. Yeah, low cost, easy to administer, but not suitable for many surveys because questions can't be explained. You're just observing. You're watching the cars going by. So there's no further data that can be taken from that individual car passing by other than the colour that you were told to collect in the first place. Okay, so with univariate and bivariate data. Now, when you're collecting your data, okay, so for example, you have 6 people in front of you. What age are you? What age are you? What age are you? What age are you? If you ask people for one piece of information about themselves, then the data that you have collected is called univariate data. It's one piece of information per subject. If you were to say gender and age, well, then you're starting to get 2 pieces of information about every subject, which is bivariate data. So very, very quickly, you begin to notice that the subjects under test, you can take 1 piece of information, 2, 3, 4 pieces of information from each subject, and then you can build up quite quickly a decent amount of information about each subject. So univariate and bivariate data simply means 1 piece of information or 2 pieces of information. Okay, so univariate as we have it there, and bivariate, hair color or gender, number of people and the rooms in the house and so on. So just keep it in mind again, it's a very important word that we need to use when we're moving forward. So how do you design a questionnaire? Well, it's a set of questions that you're going to try and obtain data from. So you've got to make sure the questions are clear, they are concise, they're understandable, and they're easily answered. Okay, the people who will receive the questionnaire are your respondents. And you make sure that your questions are logical and they're in a logical order. So name, address, people expect that. Name, address, telephone number, etc. They expect it in that order, all right? And then basic questions, getting down into the more nitty-gritty questions as you go along. So be clear about who is to complete it. So when the census arrives, the first thing it says is the head of the household is to fill out this questionnaire before a certain time and a certain day. So it's very, very clear as to who, when, and where this thing has to be filled in. Okay. Start with simple questions. Be clear about how the questions are going to be, how the answers are going to be recorded. Be as brief as possible. Nobody likes a huge, big, rambling question. Funny enough, Project Maths has loads of them, but for questionnaires, you keep them as brief as possible. Let the questionnaire be something people can do quickly, because if they can do it quickly, they will answer it. And be clear where the answers are to be recorded. Tick here. Mark this box. You'll often see mark below or tick the following box, that they're telling people where they should answer the questions. The questions themselves should be short, use simple language, provide tick boxes, be clear, be concise, be, if possible, yes/no answers. Don't be leading. Don't cause embarrassment. Don't offend anybody. Be relevant to the survey. So don't go off on a tangent collecting information about their granny when you want to know what type of glasses they prefer. Okay, so just don't go off track. Keep on track with your questions in relation to what you're trying to collect the data for. And don't be open-ended, which invites people to write down their responses. You could get a rambling answer. You know these questions you often get, if no, explain why, and they give you this huge big box. What the hell with that? But some people fill them in. Yeah, if you ever watched the program, what is it? What's that program called? Four in a Bed. Yeah, they often say breakfast, and you see some people fill in excellent, great, poor. Then some will go on with an essay. Yeah, there's nothing worse than getting back an answer that's an essay. So always make sure that the space to be filled in is limited. Keep people who are answering your questions to give concise answers. Okay, so when you collect your data, then what do? You put it into a table. particularly into what we call a frequency table. And the frequency table shows how often a given event will occur. So a tally row using marks bunched in groups of 5s should be included. So if you ever find yourself at the elections and you're doing a tally, as the boxes are opened, you're counting the votes. 1, 2, 3, 4, 5. So it's like this. It's 1, oops, Daisy. What's that happening? Oops, sorry. It's pen. Oh, it's not working. Okay. Go away. It's 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5 all the way across. And then 1, 2, 3, 4, 5. So every time you bundle 5 together, it's far easier to count at the end. Okay. Let's just go back there. So tally row, that's what we talk about, 1, 2, 3, 4, 5. So you're bundling them up in 5s, making them easier to count when you're finished. Histograms and standard deviations. The shape of a histogram reveals the size of the standard deviation. Now, I'm not going to get into this today. I'm going to leave it there in relation to standard deviation because that's just giving you a flavour of what's to come. What I am going to ask you to do, and I'm going to send you some questions on this, is just on the basis of all that lingo that you've come across, all the lingo that's involved in your, forget about the tables, in your designing your questionnaire, how to select your samples, how to gather your answers, how to produce your answers, how to actually display your answers, and how to get the data back from that. The most important thing that we've looked at in the previous 40 minutes or so is how to randomly sample a population. Okay, so a population being the big whole that you're going to select from, and then the sample trying to reflect the whole population as best you can, being free from personal bias and being as random as possible. Okay, I've spoken enough. There's plenty there to learn, plenty to get on with. I'm going to send you the questions. I did think there was questions on these slides, but I'm going to send you the questions in a separate email, and just for you to go over and make sure you understand the terminology and so on. And again, if there's any clarification needed, please send me an email, get back to me, and fire me the questions. Make sure they're brief and concise and I can answer them easily, but send me as many questions as you want and we'll try and clarify them for you.